Welcome to the next set of notes for Math 135 Intro to Stats. In this video, we're going to cover Module 4, Part 3, looking at calculations of range and quartiles. So the first thing we're going to look at is how to calculate the range of a data set. So the range is going to be found by taking the largest data value and subtracting the smallest data value. So it's the largest number minus the smallest number. So we have a new data set that we're looking at for these notes. We're going to find the range of this data set. So our largest number is 99, and our smallest number is 57. So my range is going to be equal to 99 minus 57, which is, I believe, 42, but I'm just going to double check that because I'm known for making mistakes with subtraction. All right, 42, and that's our range. Make sure when you calculate range, you don't just leave it as this subtraction here. You actually need to find a single number to describe the range. So range is pretty simple. Just find the biggest number, subtract the smallest number. So now what we're going to look at is how to determine and interpret quartiles. We're going to look at determining what those quartiles are first, then we're going to talk about how we interpret quartiles. Okay, so there are three values that we're going to look at when we're finding these quartiles: Q1, Q2, and Q3. We're going to start by finding Q2, which is also known as the median. Okay, once we find the median, Q2, we're going to then find Q1 based on everything less than the median, and Q3 based on everything larger than the median. So let's go ahead and just get into this example. So I have a data set here. I was really nice, and I've already put it in order for you guys. So we're going to go ahead and find the median, or Q2, first. So we need to remember first figure out how many data values do we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13 numbers. So n equals 13. So it's an odd number. So to find the median, I'm going to use the formula n plus 1 over 2. So here our n is 13 plus 1 over 2. So that's 14 over 2, which is 7. So now I'm going to go in and I'm going to find the seventh number. 1, 2, 3, 4, 5, 6, 7. So the seventh number is 77. So Q2 is equal to 77. That's the first step. Find Q2. Okay. So now what I'm going to do is I'm going to look at everything that was less than Q2. So to find Q1, I'm going to look at these numbers here. So 0, 50, 60, 65, 67, and 70. So I'm not going to include the median. I'm going to look at everything less than the median. So I'm going to go ahead down here. I'm going to rewrite these numbers. So 0, 50, 60. I'm going to do it in black. 65, 67, and 70. So these are all of the numbers that were less than my median. So to find Q1, I'm going to find the median of these numbers. So now I have 1, 2, 3, 4, 5, 6 numbers. So I'm going to find the median of these numbers. So remember, with an even number of values, we want to use n over 2, which is going to be 6 over 2, which is 3, and n over 2 plus 1, which is 6 over 2 plus 1, which is 4. So I need to go find the third and the fourth values. So 0 is 1, 50 is 2, 60 and 65 are 3 and 4. And I'm going to go ahead and find the average of these two numbers, or the mean of these two numbers, by adding them together and dividing by 2. So 60 plus 65 divided by 2 is 62.5. So my Q1 is 62.5. And now finally, for the last one, I'm going to find the median of the upper half of the data. So I'm going to come back up here, and I'm going to look at everything that is larger than the median. So that's 82 all the way up to 120. I'm going to take these numbers, and I'm going to find the median of these numbers. So again, down below, I'm going to rewrite them. So 82, 85, 90. I know there was 91, and I don't remember the last two. 92 and 120. 92 and 120. All right, so I've rewritten my data. It's already in order. And same thing here. I have 1, 2, 3, 4, 5, 6. So I have 6 data values. So I'm going to be doing the same thing that I did up here. I'm going to be doing n over 2 and n over 2 plus 1. I have the same number of observations, so I can go ahead and just say, okay, I'm looking at the third and the fourth numbers. I had 6 observations for my lower half. I have 6 observations for my upper half. So all of that stays the same. So now I can go ahead and calculate my Q3. 90 plus 91 divided by 2 is 90.5. So Q3 equals 90.5. So now I found all 3 of my quartiles. We started by finding the median of our entire data set, which gave us Q2. Then we looked at everything less than the median to find Q1. We found the median of that lower half of the data. And then finally we found Q3 by looking at everything above the median and finding the median of that. So now let's go ahead and put these back together and look at what we've created. So I've relisted all of the data here, and I've color coordinated it so that we can see why they're called quartiles. As you can see, I have 4 colors, and there are 3 numbers in each color. So what I did by finding these quartiles is I've split my data set into 4 sections. So here is the first section. Okay, here's the first quarter. Here's the second. Here's the third, and here's the fourth. And then my Q1, my Q2, and my Q3 serve as those cutoff values for each of those quarters of my data. Okay, so that's why they're called quartiles, is because they split our data into quarters, or into 4. All right, so we're going to look at one more calculation with these quartiles, and that's the IQR, also known as the interquartile range. The interquartile range is found by taking the value of Q3 and subtracting the value of Q1. So we're looking at the range of those middle quartiles. So we're looking at what's the range from, change colors real quick. What's the range from here to here? That's what we're looking at with that IQR. Let me write that down. IQR. So for this example, our Q3 was 90.5 and our Q1 was 62.5. So that's what we need to find in this example. So IQR equals 90.5 minus 62.5, which equals a number. You probably already found it. It is 28. So our interquartile range, the range of numbers for this middle section of our data, is 28. So finally, we're going to look at what this represents in terms of how much of our data is here. So here's a graphic that I have. So the first thing we did was find the median, and that split our data in half. So we had 50% of our data below the mean, or not the mean, the median, and 50% of our data was above the median. Then we looked at that bottom 50% and we cut that in half by finding the median. So now we've split that bottom 50% into a lower 25% and then an upper 25% of that bottom 50%. We repeated that for the top 50% of the data by finding Q3. So then we had from the median to Q3 was 25% of my data, and Q3 to the maximum was 25% of my data. And then finally we found the IQR by taking Q3 minus Q1, and that also represents 50% of my data. So 50% of my data is in this interquartile range. So up here, 28. 50% of my data is in this range of 28 numbers. Okay. So this last graphic is going to be really helpful, especially in the next section that we do. We're going to create a box plot. And it's going to be really important to remember what percentages of the data are in each of these sections that we've created. So that's it for this section of notes. So coming back up to the top, so we started by looking at the range, which was the largest number minus the smallest number. Then we found each of these quartiles. So Q2 is the median. Q1 is the median of everything less than Q2. Q3 is the median of everything greater than Q2. And then finally we found the IQR, which was the third quartile minus the first quartile. So that's it for this video.